Right, in this one section, we're going to be looking at using a summary chart to solve probability distribution problems. We're going to use exercise number 7, page 219 in your book. Now here we're solving the probability that at most 2 of 6 offspring peas have green pods. So here we're looking at Mendel type of stuff. So we're asking several questions here. So we're looking at the probability of getting that. Then we're asking, is 2 an unusually low number of peas with green pods among 6? And then what is the reasoning for our decision? So let's take a look at this. First of all, we need to be clear what is the question asking for here. So again, before we leap straight into numbers, we need to stop and go, what are we actually trying to answer with this question before we go any further? So we're looking for probability of 2 or less green pods. Notice I've taken the question and now I've translated it into the probability layout that we're more used to having so that we can move forward with this. So we're looking at P of 2 or less green pods. Now, what does that look like in a probability formula? Take a moment and sketch that in, and then turn the video back on, and let's check it together. We should have gotten something like this. So P of 2, right, or less. So P of 2 plus P of 1 plus P of 0. So again, we were looking at the at least as extreme. 2 is the cutoff point, but we're looking at 2 and any others that are as extreme as 2. So when we're going to go through and solve this formula problem, we're literally going to pull our numbers here from the table on the right. So probability of 2 is 0.033, probability of 1 is 0.004, and probability of 0 is 0.00. So when we add those together, we get 0.037. So that is our probability that at most 2 of the 6 offspring peas will have green pods. So there's our answer. Now the next thing we're going to be looking at is this an unusual low number of peas with green pods? In order to answer this kind of question, I like to first actually move down to the third part, which is why or why not. So basically, here's where you need to develop your reasoning that you're then going to use to answer the second part of the question. So we're going to apply our rare event rule. Remember, we've been looking at this before with 0.05. So we set up our formula. Is it a true statement that 0.037 is less than or equal to 0.05? The answer is yes, this is a true statement. So, yes, then this is an unusually low number. Now I'm going to have you do a second problem very similar to this one. You're going to do this on your own. So we're not going through the calculations here. We just did them above. If you need to back up and watch that video, that section one more time before you move into this next exercise. So we're going to do number 28 on page 210. And we're looking at the probability that 5 or more of the 6 offspring peas will have green pods. Then we're going to ask ourselves if this is an unusually high number of offspring peas with green pods and be able to provide an argument for why or why not. So pause the video here, answer that first part of the question, then check your answer, and then we'll move on to the next part. Okay, here we will be looking at the probability that 5 or more of the 6 offspring peas will have green pods as 0.534. So again, we would be taking our probability of 5, which is 0.356, and we're going to add in our probability of 6. Because again, we're asking 5 or more. So when we add those together, we get a probability of 0.534. Now, applying your rare event rule, determine whether or not this is an unusually high number of offspring peas with green pods. So pause the video again, set together that rare event rule, get your answer, and then turn the video back on and let's check it together. Okay, so you have the mathematical formula is 0.534 less than or equal to 0.05. Is this a true mathematical statement? No, this is not an accurate statement, so no, 5 or more is not an unusually high number of green pea pods for this problem.